Okay, so now we're going to talk about 7.2. And I know the video I gave you from Prof. Rob Bob has some content that's not in your book. And the content he gives you that's not in your book could actually be helpful if you can follow what he's saying. The key part that he gives you that's not in your book is called Descartes' rule. And that tells you which possible zeros to check first. Okay? So remember in 7.1, we learned the way to guess possible zeros by taking factors of the constant term and dividing them by factors of the leading coefficient, and that tells us where to begin. And so what he was showing you with Descartes' rule is saying, hey look, once you have those possible zeros, you can look at these characteristics of the function to know which ones to start with and which ones to check second or third. Okay? But the big part for us, for 7.2, is to recognize that this exponent on the leading term, okay, tells us exactly how many zeros we need to find. And this is sort of because any polynomial can be broken down into binomial factors if we allow for zeros that are non-real. So imaginary zeros. So if we allow for a binomial to be x minus 2i or something, then we can definitely say that every binomial can be broken down, or every polynomial can be broken down into binomial factors. And so if you imagine, where does this exponent come from in the binomial factorization? Well, it comes from how many binomials I'm multiplying together. Okay, so even if some of them are repeated, then that means that how many x terms that I multiply together from those binomials to get this leading term. This 3 tells me I had 3 x terms multiplied together to get the leading term. So that means I have three binomial factors multiplying together to make this binomial. So I know I'm looking for 3 zeros. Okay. So we're going to try to find those 3 zeros. Until we have 3, we're not done. Okay? So we're going to begin here. This is example A on page 356 in your book. So this is completely worked out, but I'm going to talk through it. Okay? The first thing they do is divide both sides by 2. And since we've already set it equal to 0, divided by 2 over here doesn't change anything. We basically just factored out a 2, which we can drop off because it doesn't have an x in it, it doesn't affect our zeros. Okay? So we're going to divide everything by 2. So we're going to get x cubed minus 6x squared minus 17x plus 102. Okay? Excuse me. Now the next thing they do is factor by grouping. So remember, in factor by grouping, we group 2 pairs of terms and look for a common pattern. Okay? So here we have a 1 to 6. Okay? And here we want to see if we also have a 1 to 6. Well, 17 times 6 is 60 plus 42. That's 102. So sure enough, I have a 1 to 6, 1 to 6. Now notice I want my 1 to be positive, my 6 to be negative. So I'm going to factor the negative out of these two. And it'll make the 17x positive and the 102 negative. So here's how it's going to look. I'm going to go x squared times x minus 6. So that's this part. I just factored out an x squared. Okay. And I'm going to go negative 17 x minus 6. So notice, if I multiply this back out, x squared times x is x cubed. X squared times negative 6 is negative 6x squared. Negative 17 times x is negative 17x. Negative 17 times negative 6 is positive 102. So now I have an x squared times x minus 6 minus 17 times x minus 6. So I can factor out this x minus 6, and I'm just left with x squared minus 17. Okay? So now I see that one of my zeros is 6. Okay? Because if I plug in 6 for x, it'll make this 0. Therefore, this whole left side will be 0 because these two things are being multiplied together. So one of my zeros is x minus 6. Write that over here. or x equals 6 is one of my zeros. Now I need to figure out what's going to make this part right here into 0. Well, I have an x squared, so I can't just call it 17. And there should be 2 zeros in here, because remember, I'm looking for 3. This is one of them. My other 2 are hiding in here where I have the x squared. So I need to figure out what values of x make this expression right here into 0. Okay? 17 is not a perfect square, so this isn't a difference of squares. So I'm going to have to solve this algebraically. So I'm going to say, what if x squared minus 17 equals 0? Well, then x squared equals 17 when I add 17 to both sides. And I take the square root of both sides and I find that x equals plus or minus root 17. So notice I now have my other 2 zeros. There are 2 values here, positive root 17 and negative root 17, both of which will make this into 0. So my 3 zeros are x equals 6, x equals positive root 17, and x equals negative root 17. Okay? So those are my 3 zeros. In this case, they're all 3 real. Okay? There's no imaginary numbers. There's no I. So these are 3 real roots of this expression. Okay? 3 real zeros of this expression. So let me show you one that has some imaginary roots. Okay? So the other one that I want to show you, I'm going to scroll down on the computer, is example B on page 357 in your textbook. And it goes x to the 4th minus 6x squared minus 27. X to the 4th minus 6x squared minus 27. And we want to find all the zeros. Okay? So, first notice that this actually looks like a tough thing to factor, because I have a 4, I'm missing the 3, I have a 2, I'm missing the 1, okay? But first we want to recognize that our leading term has an exponent of 4, so we're looking for 4 zeros, okay? So we're not done until we found 4 zeros. So now, in order to begin factoring this, it's helpful to recognize that, imagine that a equals x squared, okay? If a were x squared, then x to the 4th is a squared. If a were x squared, then minus 6x squared is minus 6a. There's no coefficient here, so this is still minus 27. So this is just like a quadratic, where I have something squared, something to the 1st, and something to the 0. Okay? So it's just like a quadratic. So I'm going to factor it in the same way. All right? It's just that instead of putting x, I'm going to put x squared at the beginning of my 2 binomials. So when I'm factoring a quadratic, I break it into 2 pairs of parentheses. Okay? Right here, my coefficient is 1, so I'm going to say this is x squared and x squared. X squared times x squared would be x to the 4th. Then I need factors of 27 that multiply or that add to make 6. Okay? Factors of 27 that add to make, subtract to make 6. Factors of 27 that subtract to make 6. So that's 9 and 3. They have different signs. The sign of the greater product is negative. So greater product is the 9x squared, not the 3x squared. So the 9x squared needs to be negative. The 3x squared will be positive. Okay? So now I have this factored into 2 expressions that both have an x squared in them. So again, there's going to be 2 zeros coming out of here and 2 zeros coming out of here. Notice, though, that this is a difference of squares. So I can still break that down into x plus 3 and x minus 3, because difference of squares this is a squared minus b squared, so I have a plus b a plus b a minus b. This is a sum of 2 things. That's not a thing, so it's just going to say x squared plus 3. Okay. Yep. So That's right. All right? So, now we know that negative 3 is a 0, because negative 3 plugged in here would make this 0. I have 3 things being multiplied. So any one of them being 0 makes the whole left side 0. So here I have x plus 3. In order for that to be 0, x would have to be negative 3. In order for x minus 3 to be 0, x would have to be positive 3. Okay, so 2 of my 4 zeros are x equals negative 3 and x equals 3. Okay. Now, what about x squared plus 3? When will that be 0? It's not factorable, so let me set it up to say, when is x squared plus 3 equal to 0? I'll subtract 3 from both sides. When is x squared equal to negative 3? Well, now again, remember in Algebra 1 world, we would stop here and say undefined, no solutions, right? Because I can't have something squared be negative. But now we have access to imaginary numbers. So I can take the square root of both sides and say x equals plus or minus the square root of negative 3. But remember, the square root of negative 1 is I. So I can factor this into x equals plus or minus root negative 1 root 3, which means x equals plus or minus I root 3. So again, this is 2 different numbers. X equals plus I root 3, x equals minus I root 3. So that's my last 2 zeros. Remember, I had 2 zeros here that came from these, negative 3 and positive 3. And now I have 2 more zeros, x equals I root 3, and x equals negative I root 3. So that's my 4 zeros for this expression. So I have 2 real zeros in negative 3 and 3, and 2 imaginary zeros in I root 3 and negative I root 3. So hopefully that helps you out with 7.2. Again, the Prof. Rob Bob video I do still think is helpful. He just introduces the Descartes rule, which could be helpful for you if you can follow that. If not, these things should get you there. So that's that.